Hello students, welcome to Educate. In this video, we will discuss about the third chapter of chemistry, that is chemical kinetics. First of all, what is chemical kinetics? So chemical kinetics is the branch of chemistry which deals about the rate of reaction. In chemical kinetics, which we discuss about what will be the rate of reaction. Okay, like chemical equilibrium, that was in the chemical equilibrium we study about the extent of reaction. Extent of reaction means how much reactant will convert into product. In thermodynamics, in chemical thermodynamics, we will discuss about the feasibility of a reaction. That means a process will take place or not. About that, we will discuss about those in thermodynamics. In thermodynamics, we will also discuss about the interconversion of energy. Same here. In previous chapter of electrochemistry, we have discussed about the relationship between electricity and the chemical reaction. In chemical kinetics, we will discuss about the rate of reaction. That means per unit volume or per unit time. That means per unit time how much reactant will consume or how much product will form. About those we will discuss in chemical kinetics. So chemical kinetics can be defined as the branch of chemistry which deals about the rate of reaction. That is called chemical kinetics. In an examination, question will not ask what is chemical kinetics, but simply you should know. The branch of chemistry which deals about the rate of reaction is called chemical kinetics. Okay. Now then after, let's see, in chemical kinetics we discuss only about those reactions which takes place through moderate speed. In chemical kinetics we will discuss about only those reactions which takes place through moderate speed. That is neither very fast nor very slow. There are some reactions which are very fast, like ionic reactions. Ionic reactions are very fast because cation and anion approach towards each other very fastly. And there are some reactions also which takes place very slow. As for example, rusting of iron. Rusting of iron don't take place in a single day, even though not takes place in a single day. So those reactions are very slow, and we will not discuss about those reactions in chemical kinetics. We will not discuss about those reactions which also takes place very fast, like ionic reactions. So in chemical kinetics, we will discuss only about those reactions which takes place through moderate speed. Now let's see what is rate of reaction. Suppose a reactant here that is converting into a product. So rate of reaction is through what speed this reactant is getting consumed. So when we consider about the change of reactant, so initial concentration will be more of the reactant, the initial concentration will be more and the final concentration will be less. The final concentration of reactant will be less and the initial concentration of reactant will be more. Whenever there will be change means always final minus initial. So final concentration is less and the initial concentration is more. That's why change in the concentration of this reactant, that will be negative. So, but the rate of reaction can never be negative. So, rate of reaction will be minus change in concentration of reactant upon time interval. But about the product, the final concentration will be more and the initial concentration will be less. So, final minus initial will be positive. So, rate of reaction will be minus change in concentration of reactant, and that will be also equal to change in concentration of product per unit time. That is for this one. Any hypothetical reaction I am taking here, 2A react with 3B, there will be formation of 2C and 4D. Rate of reaction, when you consider about the change in concentration of A or B or C or D, then rate of reaction will be always same. Either you consider about the change in concentration of A, B, C or D, always the rate of reaction will be constant. So here watch out, if 2A will consume in the reaction, then 3B will consume. If 4 molecules of A will react, then 6 molecules of B will react. So what happened here? Rate of reaction should be same, so we divide by the stoichiometric coefficient by the rate of change of a particular reactant. So rate of reaction will be minus 1 by 2 into change in concentration of A upon time interval. That will be also equal to minus 1 by 3 into change in concentration of B upon time interval, and that will equal to here positive. Here C will be positive because it's the product. So that will be equal to 1 by 2 into change in concentration of C upon time interval, and that will equal to 1 by 4 into change in concentration of D. 1 minus 1 by, that means 1 by 4 into change in concentration of 1 by 4 into change in concentration of D upon time interval. That is actually what is chemical rate of reaction. Rate of reaction means rate of consumption of reactant or the rate of production of the product. If stoichiometric coefficient is different, then we divide when we calculate the rate of reaction. So we will divide by the stoichiometric coefficient to the change in concentration, either in product or in the reactant. Now, two concepts there is. One is average rate of reaction. Average rate of reaction. And another one is instantaneous rate of reaction. Instantaneous rate of reaction. So just consider about yourself. Suppose in every month there be test conducts in your school. So 1, 2, 3, 4, 5, 6. That is 6 months test has been conducted and a half yearly test. Then after again January, February, March, April, May, June, July, August, September, October, November and December. These 12 months the test will conduct, and then after there will be final examination. So in different tests any students will have different score. Oftenly in different tests students have different scores depending on in which examination he have labored hard, in which months the students have devoted more time in the study. In those months his score will be high, and the months in which any student will devote less time in the study, in that month the score will be less. So just like this one will be instantaneous marks, that is marks in the January, that will be instantaneous marks. Marks in February, instantaneous marks. Marks in March, instantaneous marks. Total here 14 tests has been conducted. So average when we have to calculate, so you will add all of them and then after divide by 14. So that will be average marks scored by any student. Same here, instantaneous rate of reaction means rate of reaction at a particular instant of time. So here time interval will be less, and average rate of reaction when the time interval will be large, that will be called average rate of reaction. In instantaneous rate of reaction, the time interval will be less, and in case of average rate of reaction, the time interval will be large. So that means instantaneous rate of reaction means rate of reaction at a particular instant of time, and the average rate of reaction at a definite time interval, that will be called average rate of reaction. There is given here R has been converted into product same, and so change in concentration of reactant, that was change in concentration of reactant is that much, final minus initial, time interval is this one, so that has been changed here. Decrease in concentration of R upon time interval, that was, so about that we have already discussed. Now let's see another concept, that is here when the graph of concentration of reactants and the time interval will be given, then how you will calculate the rate of reaction. When the graph of the concentration of reactant versus time interval will be provided, then how you will calculate the rate of reaction. By this graph we will calculate just the concentration of both of them, that means average rate of reaction and the instantaneous rate of reaction. We will also discuss here what will be the average rate of reaction when the graph of the concentration of reactants versus time interval will be provided, and we will also calculate the instantaneous rate of reaction when the graph of concentration of reactant and the time interval will provide. Okay, so let's see here. Firstly, let's see first how to calculate average rate of reaction. Suppose here it is given 0.1, 0.2, 0.3, 0.4. Oh, sorry. Time is here. Suppose it is 1, 2, 3. This is time interval, and here is 0.1. There I have taken concentration of reactant. Suppose you will have to find out the average rate of reaction at t equal to 2 seconds to t equal to 7 seconds. You will have to calculate the rate of reaction at t equal to 2 seconds to t equal to 8 seconds. So go on the graph. At t equal to 2 seconds, concentration is that much. That means nearly 0.4. That is initial concentration. And t equal to 8 seconds, concentration goes on the graph. Concentration here is that much. That is 0.15. So final concentration of reactant is 0.15, and the initial concentration of reactant is 0.4. So that will be equal to negative sign here. final concentration 0.15. So 0.15 minus 0.4, that much mole per liter. Concentration will be here in mole per liter. That upon time interval is 8 second minus 2 second. So calculate that. That will be the average rate of reaction between the time interval of 8 second to 2 second. Same here, when the concentration of product versus time interval will provide, then also we will calculate the average rate of reaction during a particular time interval in the same manner as we have calculated the average rate of reaction when the concentration of reactant versus time interval was provided. Let's see here how, suppose same here as we have did same here. Same, you have to calculate the average rate of reaction at time interval of 2 second to 9 second. So 2 second to 8 second. So goes on t equal to 2 second. So suppose here 2 equal to 2 second. Its graph is here. That means 0.45. That means at t equal to 2 second, the concentration of reactant is 0.45. And at t equal to 8 second, goes on the graph. And here concentration is 0.75. So initial concentration of product is 0.45 and the final concentration of product is 0.75. So in that case, rate of reaction, that means average rate of reaction at the time interval between 2 to 8 seconds, that will be equal to final concentration is 0.75. So 0.75 minus initial concentration is 0.45. So 0.45. And time interval is 8 second minus 2 second. So here unit will be mole per liter per second. Here also unit will be mole per liter per second. So unit of rate of reaction is mole per liter per second. So when a reaction will take place inside the liquid, when the reaction will take place in the liquid phase, then the unit of rate of reaction will be mole per liter per second. And just we also find out the rate of reaction when gases will be involved. Suppose a gas P that's react with the gas Q and there is formation of the gas S. So rate of reaction will be here. There will be change in pressure, partial pressure. There will be change in partial pressure of P, change in partial pressure of Q upon change in partial pressure of S. That's you can also write minus change in partial pressure of P upon time interval. That will be also change in partial pressure of Q, change in partial pressure of Q, that upon time interval, and that is also equal to change in partial pressure of S upon, not here this one, change in partial pressure of, that means rate of reaction will be equal to, when gases will involve, so rate of reaction will be equal to change in partial pressure of P, that upon time interval, that will be also equal to change in partial pressure of Q upon time interval, that will be also equal to change in partial pressure of S upon time interval. So that is here. So unit, when the reaction will take place in gaseous phase, the unit will be partial pressure or any pressure, that will be either atmosphere or bar, whatever you would like, that upon time intervals, means second inverse or Pascal per second inverse. So there will be, when the reaction will take place in liquid phase, the unit of rate of reaction will be mole per liter per second, and when the reaction will take place in gaseous phase, the unit will be atmosphere per second or bar per second or any other unit you may choose. That is here. That means the unit of pressure upon time interval, that's unit here. Here the unit is change in concentration, that upon time interval. Okay, that was just about the unit. Let's see about how to calculate the instantaneous rate of reaction. In the graph that has been shown also. So here, suppose t equal to, at this time interval, the rate of reaction will have to calculate. So at this time interval, go on the graph and draw a tangent. This tangent you may take of any length. Whatever be the length of this tangent, the value of rate of reaction will not change. Just like that, in any angle, suppose this is the angle here. If you will increase this length, then even though the value of this angle will not change. In the same way, in a bucket, there is water. So it will have some density. If you will increase the amount of water, then density will not change. The mass of the water will change. The mass of water will change, as well as the volume occupied by the water, that will also change. But the density of water will remain constant. In the same way, when you will draw this length, when you will draw the tangent on this line, when you will draw the tangent, that means at this one, go on the graph and you have drawn the tangent. So whatever be the length, then this value will not change, because if length will be more, then change in concentration will be more and the time interval will be also more. If the length of this tangent will be less, then change in concentration will be less and the time interval will be also less. So whatever be the length of this change here, or whatever be the length of this tangent, the value of the rate of reaction will remain same. So you have plotted a here tangent, and on that tangent, suppose you have drawn this tangent at t equal to here. So at t equal to this one, just I am taking from here. Suppose that much length I have taken. So at t equal to this one, the concentration is that much. At t equal to this one, concentration is that much. So suppose here I have taken 1, 2, 3. So at t equal to 1, the concentration is 0.7 mole per liter. And at t equal to here, 1, 2, 3, 4, 5, 6. At t equal to 6 second, the concentration is 0.2 mole per liter. So the rate of reaction, instantaneous rate of reaction, that means at t equal to, we have drawn at this one, at 3 seconds. So here we have taken suppose I have to calculate the rate of reaction at t equal to 3 seconds. So at t equal to 3 seconds, I have gone on the graph, have drawn a tangent, and then after is observing here. So at this one, at t equal to 1, I have realized at t equal to 1 second, the change in concentration is 0.7 mole per liter, and at t equal to 6 seconds, the concentration is 0.2 mole per liter. So rate of reaction at t equal to 2 seconds, at t equal to 3 seconds. The rate of reaction at t equal to 3 seconds, that will be equal to, at t equal to 3 seconds, that will equal to final concentration is 0.2, so minus sign 0.2 mole per liter minus here initial concentration is 0.7 mole per liter, that upon time interval is 6 seconds and 6 seconds minus 1 second, that is the time interval. So in this manner you can calculate the instantaneous rate of reaction at a particular instant of time. The time at which you will have to calculate the instantaneous rate of reaction, you will have to draw the tangent on that tangent on the graph at that instant of time, and watch out what is the change in concentration upon time interval as I did. Okay, same here in the case of product. Suppose at this time, here again I am drawing like this. Suppose at t equal to 5 seconds, you will have to find out the instantaneous rate of reaction. So go to the graph at t equal to 5 seconds, draw a tangent. Whatever be the length of this tangent, that doesn't matter. So now at t equal to, at this one, at 1.5 second, the change in concentration is 0.6 mole per liter, and at t equal to here 7 seconds, the change in concentration is 0.9 mole. At t equal to 1.5 second, the concentration of product is 0.6 mole per liter, and at t equal to 7 second, the concentration of product is 0.9 mole per liter. So rate of reaction at t equal to 5, that will equal to here change in concentration of reactant. So final concentration is 0.9 mole per liter and initial concentration is 0.6 mole per liter. So that will be 0.9 mole per liter minus 0.6 mole per liter. That is change in concentration, and time interval will be here you have taken 7 seconds and it's come 1.5 seconds. So 7 seconds minus 1.5 seconds. So in this manner you can calculate the instantaneous rate of reaction. That means if the graph of the concentration of reactant versus time or the graph of concentration of product versus time will be provided, then you could calculate the instantaneous rate of reaction as well as the average rate of reaction. Okay, what is the unit of rate of reaction? That's you are already aware. Now let's see about this question. So in this question, what is here? In this question, the time interval has been given, and at a different time, what is the concentration of reactant is that has been provided. So very simple to calculate this question. Here the average rate of reaction, during different time intervals you have to calculate. So just say watch out here, between time interval of 50 to 0 second, what is that here? So here it is reactant, concentration of reactant. So rate of reaction, that will be equal to final concentration of reactant minus of, firstly minus change in concentration. So final concentration this one minus this one. So 0.0905, that much mole per liter minus 0.1 mole per liter, that upon time interval is 50 seconds. Okay, so that means that will be equal to 0.1 minus 0.0905, that much mole per liter, that upon time interval is 50 seconds. So that you can calculate very easily. Same way, you can calculate the rate of reaction during the time interval of 100 second to 50 second. So rate of reaction during the time interval of 100 second to 50 second, that will equal to final minus firstly into final concentration this one minus initial concentration is this much. So so that will be equal to here 0.0820, that much mole per liter minus 0.0905 mole per liter, that upon time interval will be 100 second minus 50 second, that much here, negative of minus sign here. So finally this minus this upon this, very easily you can calculate. Okay, now let's see the another topic. These are the some few topics which you can do very easily. Instantaneous rate of reaction, what is that? We have already discussed. It is here average rate of hydrolysis of butyl chloride, that has been given. Average which I have calculated, that has been shown here. Okay, what is instantaneous rate of reaction? That's we have calculated also. This question, this topic is very easy, but easy, same concept which we have discussed right now. Then after this question, yes, here, this question is too much important, and this question has been asked in 12th board examination a number of times, and solving this question is not difficult. Usually students consider this question as difficult, but actually you will have to only apply the concepts which we have used to solve the questions or during previous one, and that of the graph here not utilized. So let's see here the same simple concepts you have to apply, and you could solve this question very easily. Watch out here. Well, read the question firstly. Now watch out. N2O5 has been decomposed and there is formation of NO2 and O2. The initial concentration of NO2 has been given. So you have to find out the rate of reaction. That means the concentration of N2O5 has changed from 2.33 mole per liter to 2.08 mole per liter. So obviously initial N2O5 is a reactant. So initial concentration of N2O5 will be more and the final concentration of N2O5 will be less. And time interval is 184 minutes. So you can calculate this one in mole per liter per second also, in mole per liter per minutes and mole per liter per hour. So let's see here. So rate of reaction, that will equal to minus of change in concentration of N2O5 upon time interval. So that will equal to here, final concentration is 2.08 mole per liter. So minus of 2.08 mole per liter minus initial concentration is 2.33 mole per liter. That upon time interval is how much? 184 minutes. So if you have to calculate in meter per second, then you will have to convert 184 minutes into second. So that will be 184 into 60, that much second. So that will be 2.33 mole per liter minus 2.08 mole per liter. That upon time interval is say 184 into 60 second. When you will now calculate this one, how much is coming? So after solving this one, it will come 1.13 into 10 power minus 5. 1.13 into 10 power minus 5. And that's why here it is mole per liter. So mole per liter per second. That is to calculate in per minutes. If nothing you will have to do, simply that will be 2.33 mole per liter minus 2.08 mole per liter, this upon 60. So here this 60 will be not, simply by 184. That means here it will be 2.33 minus 2.08, that much mole per liter upon 184 minute. Okay, so that means what the value here is, if you will multiply by 60, then you will get. So if you have calculated here, because that has been divided by 60, so came this one. So to this value, when you will multiply by 60, so you will get in per minute. So this one here is, what is here? So multiply by 60. That will be 6.78 into 10 power minus 4 mole per liter per minute. Okay guys, very simple here, 6.78 into 10 power minus 4 mole per liter per minute. That will be in terms of R. So here per second you have already calculated, minute here already. So in R what will be happen here? So you will have to convert here minutes into hours, here minutes. So that will be 2.33 minus 1.08, that upon 184 upon 60, that much R. So this value you already calculated. So when you will multiply by 60, this value, when you will multiply by 60, you will get desired. So 6.78 into 10 minus 4 into 60 mole per liter per hour. So that means 4.06 into 10 minus 2. So that will be here in terms of R 4.06, that will be 4.06 into 10 power minus 2. That is the answer desired. Very easy. Now same here you have to also calculate rate of production of NO2. Now goes on the question, what is that? So rate of reaction here is equal to 1 by 2 minus of 1 by 2 into change in concentration of N2O5. That means upon time interval. So delta N2O5 upon delta T, that is actually the rate of decomposition of N2O5. So rate of reaction is half of the rate of decomposition of N2O5 minus change in concentration of N2O5 upon delta T. That can be also considered as the rate of decomposition of N2O5. That means the rate of reaction is the half of the rate of reaction is half of the rate of decomposition of N2O5, and that can be also written as here product here. So 1/4 into rate of production of NO2, and that will be equal to rate of production of O2. So the rate of reaction in this equation is, the rate of reaction is half of the rate of decomposition of N2O5, and that is also equal to the rate of production of NO2 and that of the rate of production of O2. The rate of production of this one. Okay. So okay. So rate of reaction is half of the rate of decomposition of N2O5. That is also equal to rate of production of NO2 as well as 1/4 the rate of production of NO2 as well as the rate of production of O2. Okay. So now the question is asking rate of production of NO2. So rate of production of NO2 will be 4 into rate of reaction. So rate of reaction you have calculated here. So in terms of hours, minutes and seconds, all of you have calculated. So rate of production of NO2, that will equal to 4 into, because this one 4 here into rate of reaction. So mole per liter per minute you have calculated here. So this one, multiply them. So how much? So after that, so that is 2.712 into 10 to the power minus 3. That is okay, guys. Very easy question. Now let's see the another question. So this one question is very easy here, as we have discussed the previous question. Like that, you can also calculate. Very easy question, and even though this question is easier than that of this question also. Now 3.2. This question is also quite easy. So all of you try to solve this question, and definitely you will solve this question. Even though if you need any help, then you may contact to the Educat in the comment box. You comment, and definitely I shall help you. For this class, it's all. Then after, in the next video, we will discuss about factors influencing rate of reaction. It's all for today class. Thank you, Team Educat.